The usual arithmetic operations like addition and subtraction when applied over pointer type variables behave in a different way. For example, the plus plus operator when applied over a regular value will increment its value by 1. But it will have an altogether different effect when applied over a pointer type variable. When arithmetic operators are applied over pointer type variable, the outcome depends upon the declared data type of the pointer variable. The general rule governing the outcome is this. Adding n to a pointer type variable increment its value not by n but by n times the size of the data type, where n is any positive or negative integer. For example, applying the unary increment operator over an integer type pointer variable will increment its value by 4 and not by 1, assuming that an integer requires 4 bytes of storage. By adding 3 to a floating point number, increment its value by 12 not by 3, assuming that a double requires 4 bytes of storage. Let us illustrate this rule through a few examples. This program declares an integer type variable, obtain its base address by applying address of operator over the variable and store the obtained address in pointer, which is an integer type pointer variable. The first print statement prints the value of PTR and the second print statement applies the unary increment operator over PTR and then print its value. The output of the two print statements on my system is this and this, and the corresponding decimal numbers are this. It should be noted that the printed values will vary from system to system, but the difference between them, which is 4, will be same on any system. This illustrates that the unary increment operator has incremented the value of an integer type pointer variable by 4 instead of 1. This program illustrates the concept again, but taking a short type pointer variable instead of an integer type pointer variable. In this case, the difference between the values printed by the two print statements will be 2. You are advised to verify the output by running the program. Let us modify this program with a little bit. Instead of applying the unary operator on the pointer variable, let us add an integer to it. This pointer is similar to the previous one, except that instead of applying the unary operator on PTR, it adds 10 to it. The output of the two print statement on my system is this. Notice that the second value is 20 more than the first one. 20 is 10 times the size of the short variable. In this example, we observed that trying to increment a short type pointer variable by 10 gets it incremented by 20 instead of 10. You will witness a similar effect when you apply a unary decrement operator over a pointer type variable or subtract an integer value from a pointer type variable. You are advised to write a program and verify the same. Pointer arithmetic forms the basis of many array-based operations. You should be very clear about this concept. Let us reiterate the pointer arithmetic rule stated earlier along with few more relevant points. Rule number 1. The plus plus and minus minus operators when applied over an ordinary variable will increment or decrement it by 1, whereas when applied over a pointer variable will increment or decrement it by the size of the data type of the pointer. Rule number 2. The plus n and minus n operator when applied over an ordinary variable will increment or decrement it by n, whereas when applied over a pointer variable will increment or decrement the pointer by size of the data type of the pointer multiplied by n. N should mandatorily be an integer type like char, short, int, long, otherwise code will not compile. Rule number 3. Multiplication and division operators as well as adding two pointer variables is not allowed. Gives compile time error because the resulting value needs to be interpreted as pointer, and in these cases the resulting value could be any arbitrary number, which may not necessarily be interpreted as a pointer. Last rule is all the relational operators work perfectly with pointers. Their usage depends upon the context. Some examples will be covered in our next video, which deals with problems related to array. Bitwise operator cannot be applied over pointer data types, though they work with integer data types. Pointer arithmetic is applicable over void pointers too. In this context, the void pointers behave like an ordinary number and plus plus operator advances them by 1. In this example, the output of the two print statements on my machine was this. The difference between the latter and the former is 1. Since the compiler does not know the associated data type of a void pointer type variable, it increments it by 1 when a unary increment operator is applied over it. It was mentioned that an array can hold more than one value, but they should be of the same type and all of them occupy contiguous memory locations. The array elements occupy contiguous memory location is very important aspect of arrays. Various array specific operations rely upon this fact. This fact, when combined with pointer arithmetic, which we have just finished discussing, brings out a very interesting phenomenon. Let us understand the memory layout of array elements and the consequences of applying pointer arithmetic over them.